Fabrication process flow. Basic steps. Note that each processing step requires that certain areas are defined on chip by appropriate masks. Subsequently, the integrated circuit may be viewed as a set of alternated layers of doped silicon, polysilicon metal, and insulated silicon dioxide. In in uh, general a layer must be patterned. A layer must be patterned before the next layer of material is applied on the chip. Outlined on the chip. The process used to transfer a pattern to a layer on the chip is called lithography. Lithography, since each layer has its own distinct patterning requirements, as the lithographic sequence must be repeated for every layer using a different mask. To illustrate the fabrication steps involved in patterning silicon dioxide through optical lithography, let us first examine the process flow shown in figure. The sequence starts with the thermal oxidation of the silicon surface, by which an oxide layer of about 1 m thickness, for example, is created on the substrate. Figure B. The entire oxide surface is then covered with a silicon photoresist, which is essentially a process steps required for patterning of silicon dioxide. Here you can see this is the continued figure of the process steps. High sensitive acid resistance organic polymer, initially insoluble in the developing solution. Figure C. If the photoresistance material is exposed to ultraviolet UV light, the exposed areas become soluble so that they are no longer resistant to etching solvents. To selectively expose the photoresistance, we have to cover some of the areas on the surface with a mask during the exposure. Thus, when the structure with the mask on the top is exposed to UV light, areas which are covered by the opaque features on the mask are shielded. In areas where the UV light can pass through, on the other hand, the photoresistance is exposed and becomes soluble. Figure D. The type of photoresistance which is initially insoluble and becomes soluble after exposure to UV light is called positive photoresistance. The process sequence shown in figure uses positive photoresistance. There is another type of photoresistance which initially soluble and becomes insoluble, hardened after exposure to UV light, called negative photoresistance. If negative photoresistance is used in the photolithography process, the areas which are not shielded from the UV light by the opaque mask features become insoluble, whereas the shielded areas can subsequently be etched away by Developing solution and negative photoresistance are more sensitive to light, but their photolithography resolution is not as high as that of positive photoresist. Therefore, negative photoresist are used less commonly in the manufacturing of high density integrated circuits. Following the UV exposure step, the unexposed portions of the photoresistant can be removed by a solvent. Now the silicon dioxide regions which are not covered by a hardened photoresistant can be etched away either by using a chemical solvent, HF acid, or using a dry etch plasma etch process. Figure we note that at the end of this step we obtain an oxide window that reaches down to the silicon surface. Figure F. The remaining photoresistant can now be stripped from the silicon dioxide surface by using another solvent, leaving the patterned silicon dioxide feature on the surface as shown in figure G. The sequence of process steps illustrated in detail in figure actually accomplishes a single pattern transfer onto the silicon dioxide surface as shown in figure. The fabrication of semiconductor devices requires several such pattern transfers to be performed on silicon dioxide, polysilicon, and metal. The basic patterning process used in all fabrication steps, however, is quite similar to the one shown in figure. Also note that for accurate generation of high density patterns required in submicron devices, electron beam (e-beam) lithography is used instead of optical lithography. In here you can see in this figure the result of a single lithographic patterning sequence on silicon dioxide without showing the intermediate steps. Compare the unpatterned structure top and the patterned structure bottom with figure B and figure G respectively. The following main processing steps involved in the fabrication of an N-channel MOS transistor on a P-type silicon substrate will be examined. Thank you.